right, so this is the graph of velocity, and number 13 is asking, when is the speed decreasing? So for speeding up and slowing down, you need to look at both velocity and acceleration. So I'm gonna make a sign chart with both of them on. And so this graph goes from 0 to 8, and the other points I'm gonna need to include are 2 and 4 and 6. So basically all the even numbers here. And so since this is velocity, velocity is positive when this graph is above the x-axis and negative when it's below. So positive from 0 to 2, and then negative from 2 to 6, and then positive again from 6 to 8. And then acceleration is the slope of velocity. So now we're looking at increasing and decreasing. So acceleration is negative from 0 all the way until 4, and then positive from 4 to 8. And so 13 was asking, when we look back at it, speed is decreasing. So that would be when velocity and acceleration are opposite signs. So that is going to be from 0 to 2 and from 4 to 6, because velocity and acceleration are opposite signs there. And so just to bring up some of the other things I was mentioning, I had some people write, instead of this, they wrote they. They won't take that on the AP exam. Also, if you just wrote are opposites, they won't take that. It's opposite sides. So I know that sounds like it's being really picky, but just write it exactly like I'm showing it to you to get full credit. All right, and then 11. All right, so this is the position function. And we have seconds and we have feet, so those are the units. And letter A is asking, when is the particle at rest? So that is going to be velocity equals 0. So I'm going to get this velocity function and set it equal to 0. So that would be 3t squared minus 6t minus 9 equals 0 because it said at rest. I'm going to go through and divide everything by 3 just to make the numbers a little bit smaller. And then that is going to factor. So that will be t plus 1, t minus 3. And you can't include the -1. We don't do negative time. So I can't get a result from that. So just time is 3 seconds. And then letter B is asking, is the particle speeding up or slowing down at time 8? Justify your answer. Okay, that's the same thing 13 was asking. It's just we don't have a graph to look at, so we're going to have to actually plug 8 into the velocity and acceleration. So we're going to get velocity at 8. And actually, you don't even need to figure out what it actually is. You just need to figure out if it's positive or negative. So if we plug in 8 here, 8 plus 1 is positive, 8 minus 3 is positive. So v of 8 is positive. And then I need to get the acceleration function because I don't actually have that yet. So that will be derivative of velocity. So here's my velocity. I'm just going to do that derivative. It will be 6t minus 6. And we're going to do acceleration at 8. And again, a lot of you put like the exact number that it was. That's totally fine. It's not necessary though. You just need to know whether it's positive or negative. So if we plug 8 into this, we're going to get a positive result. And so since they are the same sign, the particle is speeding up. So the particle is speeding up at time 8 seconds because v of 8 and a of 8 are the same sign. And a lot of you wrote because they're both positive. I took that and that's totally fine, and they would take that on the AP exam too. But just be aware, if they were both negative, that would still mean speeding up. So just be aware, even if they're both negative, it'll still be speeding up as long as they're the same sign. All right, and then number 4. Right, 4 is asking, at what time does the particle change direction? And this is the position function that we were given. And again, time is seconds and distance is in feet. So if we want to know when the particle changes direction, we have to know when the particle stopped. So that's going to be velocity equals 0. It can't turn around without stopping. So this velocity is going to be 3t squared minus 3. I'm going to set that equal to 0. And so add over the 3, and then divide by 3, and then square root. So time 1 second. And just to show you on the velocity graph, if I pick a number in this section, like a half, if I plug that into velocity, a half squared would be a fourth, times 3 would be 3/4, minus 3 would be negative. And if I pick a number bigger than 1, like if I pick 2, 2 squared would be 4, times 3 is 12, minus 3 is 9, which is positive. So we have a change in direction there. The particle was moving in the negative direction and then is moving in the positive direction. All right, and then number 5 is asking for the total distance traveled by the particles. So we're going to plug into position, which let me just go ahead and write the position equation again so that we have it here. And you have to plug in the beginning time and the ending time, and then any time that the particle stopped. So it asks in the first 4 seconds. So we need 0 and 4. And then the time that the particle stopped, which we just found was 1 second. So I also need to include 1. And so plugging those into position. So if you plug in 0, you're just going to get 0. If you plug in 1, this is going to be 1 minus 3, so -2. And then if we plug in 4, 4 cubed is 64, and then that would be -12, so 52. And I like to draw a picture of what it looks like. If you don't want to, that's okay. I just think the visual helps. Our particle starts at 0, and then goes to -2, and then goes up to +52. And we're just going to add together all of the motion. So if it goes from 0 to -2, that's a distance of 2 feet. And then when it goes from -2 up to 52, that's a distance of 54 feet. And so your total is 56 feet. All right, would you guys like to pick another one? Right, 7. Is dealing with this same position function, and it says, when is the particle speeding up? So we're going to need to look at velocity and acceleration. Speeding up would be when they are the same signs. I'm actually, let me go ahead and flip over because I already have part of the sign chart on the other side here. So here's velocity. I just need to add acceleration to that to answer the question for number 7. We need to look at both velocity and acceleration. So let me get the acceleration function. Actually, did I do that already? I don't think I did for this one. Oh, well, if I already did, in any case, I can just do it again. So acceleration will be the derivative of velocity. And so that is going to be 6t. And so any number I plug into that that's bigger than 0 is going to give me a positive result. So this is always going to be positive. You would have to plug in a negative number to get a negative result, and we don't have negative time. So that would always be positive. So 7 is asking, when is the particle speeding up? That would be when these are the same signs. So we would say 1 to infinity, because velocity and acceleration are the same sign there. All right, and then I will do one more. So I'm seeing number 8. So let's do number 8. Right, so for number 8, this is the position function. And time is in seconds and distance is in feet. And 8 is asking when is the particle at rest? So that would be velocity equals 0. So we're going to get the velocity and set it equal to 0. So this derivative would be 3t squared minus 18t plus 24. And again, it said at rest, so I'm going to set it equal to 0. I'm going to go through and divide everything by 3 just to make the numbers a bit smaller. And then this is going to factor. So that is going to split t minus 2 and t minus 4. And so we actually get to keep both of those answers. So we're going to get time 2 seconds and time 4 seconds.